Hello and welcome to Student Express Review. This is Kevin, and today's topic is Unit 1 for AP Calc AB and BC limits. So let's start by defining what a limit is. So the limit as x approaches a of f of x is equal to L. That can be seen with this graph right here. So let's start by finding limits by using a graph. So the limit as x approaches 1 of f of x would be equal to 3. The limit as x approaches 2 of f of x would be equal to negative infinity. And the limit as x approaches 3 of f of x would not exist, because for a limit to exist, the left and right side both need to equal. So let's look at a table now. So using this table, the limit as x approaches 1 from the left, the values are approaching 2. And from the right, the values are approaching 2 as well. So this means that the limit as x approaches 1 of f of x is also equal to 2. So now let's look at properties of limits. So the limit as x approaches a of a constant k times f of x is equal to the constant times f of a. And then we have the limit as x approaches a of f of x plus or minus g of x. And that's equal to the limit of f plus or minus the limit of g. And you just take the limits individually. The same thing goes for multiplication and division, where you take the limits individually and then computate them out. So then we have the methods for finding limits. So we have factoring, conjugate, and trig. So you'll notice that if you just plug in each value, you would get division by 0. So you have to solve them out. So let's start with factoring. So factoring this top, we will get the limit as x approaches 4 of x minus 4, x plus 4 over x minus 4. Now these x minus 4s would cancel out, and you'd be left with the limit as x approaches 4 of x plus 4, which is equal to 8. So now looking at conjugate. So what you do is you multiply by the conjugate of the square root. So what that means is you take that square root, x plus 1, and then you flip the sign. So it'd be plus 2. You do the same thing for the top. So, and what do? You don't want to factor the top because things are going to cancel out. So you'd be left with the limit as x approaches 3 of x minus 3 times the square root of x plus 1 plus 2 all over, this would be x, and then plus 1 minus 4, so it'd be minus 3. As you can see, these cancel out. So then you're left with the limit as x approaches 3, the square root of x plus 1 plus 2, which would get you 4. So now trig. The limit as x approaches 0 of sine of x over x, this is given. So for instance, if you were to have something else like the limit as x approaches 0 sine of 2x, for instance, over x, this would be 2, because you know that the sine of x over x is 1, and then you use the properties of limits of division to solve it out to get 2. Now let's look at squeeze. So squeeze theorem is essentially if you have multiple functions, like here we have the x squared and the sine of 1 over x, you essentially have the two functions kind of squeezing to a point, and that's where this other function is squeezing through. So with this, you essentially say you bound this one function by the other function. So when you take the limits, with this example, you have the limit when x approaches 0, you get 0 for both the left and right bound, which means that this whole limit is just equal to 0. Now let's look at discontinuity. So as you can see here, there are 3 different discontinuities here. A discontinuity is when the graph isn't continuous. So at 1, there is a whole discontinuity. And at 2, this is an infinite discontinuity. And at 3, this is a jump discontinuity. And now let's look at examples. This function is discontinuous, but what type does it have? Well, it has a whole discontinuity because you can factor out the top and bottom like we saw earlier. You can't just ignore this. Even though you're canceling it out, this was still part of the original function, so it still has an impact. So even though it cancels out, this point doesn't exist. So now let's look at a piecewise. So the idea of this piecewise is that if you take the limit from the left and the limit from the right, they must equal each other. So what that means, what you can do is you can do x plus 3 is equal to k x squared. And then you can solve for this k and x value. Now let's look at limits at infinity. So these 3 limits represent 3 different cases. So this top case is when the degree on the top is greater than the degree on the bottom. And what that means, this exponent above the x cubed is greater than the x squared. So what that means is that it's increasing faster. So it means it's going to be infinity. Now let's look at this one. Although this has a squared, since we're taking the square root, it would really be 3x and then over x. And with this, you just look for the leading term, right? So it'd be 3 over 1 would be what this is approaching. Now when we have the degree on the bottom is greater than the top, and this is just equal to 0. Now we're going to look at intermediate volume theorem. This is saying that if you have this function that's continuous from the interval a to b, it's essentially saying that there must be a value from this y1 and this y2. There must be y value for every x value on that interval, in the closed interval. So that was all with limits. Hope you enjoyed. Next video is going to be unit 2, which is derivatives.